Greetings and a warm welcome into the presentation on the topic transmission media. I am Bharath and I am belonging to Computer Science Engineering Artificial Intelligence Department in Sri Venkateswara College of Engineering, Bangalore. The course which I'll be um, speaking about in this video would be computer networks, and I'll be speaking on the topic transmission media. Let us go on with the presentation. Introduction to transmission media. Transmission media refers to the physical path between sender and receiver in a computer network. It carries data in the form of electrical, optical, or radio signals. The key characteristics of transmission media are, like, the most important of those are bandwidth, attenuation, interference, and signal to noise ratio. These are the key characteristics of the transmission media which we will be discussing in the video. Now let us look on what are the different types of transmission media. Transmission media is not a single one. There are many different types among the transmission media. There are two main types. One is the guided media and the other one is the unguided media. Transmission media, in the guided one, it is confined to a physical path. Guided means the transmission from sender to the receiver goes through a physical path, and it is guided media. It is called as guided media because the transmitting message goes through a physical path, so it is connected end to end, which means it is guided to where it has to get connected. The message will not get missed in between anywhere. The three main types of the guided media, which we will look in the later part of the video. The three main are twisted pair cable. It's a type of cable which we see in the normal wires where the cables are twisted and it's like a pair of cables are twisted. And the next one is the coaxial cable, which is another type of cable used in transmission of medium, used as a transmission media. And one more, which is a recent invention, that is the optical fiber, which uses light signals to transmit information from one part to another. Unguided media is transmission is through air or vacuum. See, here the transmission is through air or transmission is through vacuum, which means the transmission is not guided. It is not meant to go to a specific part. It is just transmitted from the sender, and any system can receive it around the place because it is left in the air, it is left in vacuum. And given here is an example, that is wireless communication. Guided media example is wire communication, wired cables. Here it's wireless communication, which means there are no wires from the sender to receiver. The the information is just left in the air, and it gets received by any of the responders or transmitters which are there in the device, receiving device. The main kinds of unguided media here, which we are going to look, is radio waves, microwaves, and infrared waves. Radio waves are those which we get radio signals if we have listened to the FM, and microwaves are those which is most commonly used in cooking, but it is also used as media of transmission. Infrared waves, which we all know, it is used even in mobile phones today, and it's used in the TV laptops for, sorry, the TV remotes for um, wireless controlling of the TV, the channels, changing the channels or switching them. This is about the types of transmission media. Now let us look at a twisted pair cable, the three types which we saw in the previous slide: twisted pair cable, coaxial cable, and optical fiber. First, let us look at the twisted pair cable. This consists of pairs of copper wires twisted together. As we can see, if I can point it out with a laser here, we can see here the twisted pairs are, it's a cluster of two wires which are, that twisted in spiral, and they are kept together. What are the advantages of these twisted pair cables are? They are low cost and easy to install. So it's a advantage because it's easy to install because it has a jacket, it has a braided foil shield, it has two layer of shielding for the wire, so the wires are safe generally, and this makes it easy for installing. One of the more main advantages is that it's a low cost because this is a very simple design of making the wire, and disadvantages is they're susceptible for electromagnetic interference. When there is a twisted pair cable, if there is an electromagnetic device brought near the wire, the message gets disrupted. And one more thing is they have a limited bandwidth. It's it cannot take higher bandwidth. That's one of the disadvantage of this. And this is majorly used in telephone lines and Ethernet. This kind of a twisted pair cable, they are mostly used in these kind of applications. The next kind of cable is the coaxial cable. A central copper conductor surrounded by insulation, shielding, and an outer jacket. This, as we saw in the twisted pair cable, there was a copper wire in between those twisted wires. So here what happens, this copper wire was shielded by another two layers and then there was a jacket in the twisted pair. But in the coaxial cable, the central copper conductor surrounded by insulation shielding, there's a copper wire in between. Here there's a copper wire in between. This copper wire is surrounded by insulation, shielding, and an outer jacket. This is an insulation used, the blue part. The copper mesh here is the shielding, and then outside insulation is it's an outer jacket to protect it from any kind of physical damages. What are the advantages is that this has a higher bandwidth than a twisted pair and has better resistance to interference. So in twisted pair cables, what we had, if there was an electromagnetic device or an electromagnetic field which comes in contact with the cable, there were to be an interference, which is called as an electromagnetic interference. But here, this is an advantage of using a coaxial cable as compared to the as compared to the twisted pair cables, that there it has better resistance to such electromagnetic interferences. And one of the anything you take, there will be disadvantages. The disadvantage of using a coaxial cable is that the coaxial cable is bulkier. It's more bulkier than the twisted pair cable, and this comes at a higher cost because the shielding here is by a copper mesh, and this is mostly used in cable TV and broadband internet. So these cable TVs and broadband internets, as they are not long, but even though if it is short, if we are purchasing such a kind of cable, they are more costlier than the normal cables. Optical fiber is one of the uh, newest inventions, state-of-the-art technique, where it's made of glass or plastic fibers transmitting data as light pulses. So the data from one part to another goes in the form of light. The data here is encoded, converted into light, and the light is transmitted from the sender. The light is received at the receiver side, and then it is decoded again, and the information is taken. What are the advantages is this has an extremely high bandwidth because it is going in the form of light, and is immune to electromagnetic interference. Nothing Electromagnetic forces cannot act upon light. The coaxial and twisted cables used the copper wires, and it was not a light signal which was going. But here in the optical fiber, they do not use these kind of sorry, optical fiber uses light impulses, so light pulses. So they are purely immune to electromagnetic interference. Suppose you leave a light passing through a magnetic field or an electromagnetic field, it does not affect the path of light. The light just keeps on going. That is one of the advantage of this optical fiber, and it can be used for a very long distance. There's no problem for optical fibers. But if you have to use the um, copper wires and those cables, coaxial or twisted pair, you need to have a very long length of wire, which is very costlier also. Disadvantages is expensive installation. It's expensive because it's glass, it has cladding, coating, outer jackets, all these, and they're fragile because light reflects very fast. If it breaks in between, the light does not travel from one place to another. And the other reason it's fragile is it is using a glass, otherwise a plastic fiber. So it is very hard and it's fragile. And this is used in long distance communication, and it's the backbone of internet today. This is about the optical fiber. And one more main type which we saw was the wireless transmission, which is the unguided media. The radio waves, microwaves, and infrared waves are the three types of unguided transmission media which we saw. Radio waves is used for short to long range communication, either short range communication or long range communication. The radio which we get from outside, which we tune into FM, that is also a part of radio waves. That uses radio waves. It's just called as radio, but the reason it's called radio because it uses the radio waves for transmission of data. Microwaves are very high frequency, and they're also radio waves itself, high frequency radio waves for point to point communication. And infrared is short range communication using light waves. Infrared wave is a light, infrared is a light wave, and it's a very short range communication. If it goes too far, that communication will not work. And where is this used? As I told earlier, it's used in TV remote controls and IR sensors. The next one, let's compare twisted pair, coaxial cable, optical fiber, and this wireless. As we saw, bandwidth, optical fiber has the highest. Distance, very long distance of optical fiber is used. Wireless varies because there are three. Coaxial cable is medium, and twisted pair cable has a very short distance of transmission. The cost, very high cost in optical fiber because it's glass. Twisted pair has short distance, low bandwidth, so no problem. It uses um, a kind of lower cost. Coaxial and wireless radios are of medium cost. High interference from electromagnetic or magnetic fields in twisted pair and wireless. There's medium interference in coaxial cable, whereas if you come to optical fiber, there is no such electromagnetic interference. What are the factors affecting transmission is bandwidth. Attenuation. Bandwidth means the capacity of a medium to carry data. Attenuation is the loss of signal strength over the distance. Interference is external noise affecting the signal. Latency is the time taken for data to travel from sender to receiver. These are the four factors affecting the transmission. And in conclusion, the choice of transmission media depends on the network requirements. Optical fiber is ideal for high-speed, long-distance communication, which is so, while twisted pair and coaxial cables are more cost-effective for short to medium distances. If it's a short distance, there is no use in putting an optical fiber. You can use a normal cabled wire itself. So this is what the video was all about. Let us conclude with the presentation, and thank you very much for being a part of the video. See you soon in the next one. Thank you.